In this part of the lecture, we are going to look at process map complexity and some of the techniques for handling that complexity. Additionally, those techniques are going to lead nicely into conformance checking, and as such, we will also introduce this concept of conformance checking in this part of the lecture. But let's begin with process map complexity. So process mining tools use process maps as the main visualization technique for event logs. However, full process maps can be very large and complicated, thus requiring simplification. For example, here you can see one full process map where there is a huge number of different paths, and it's very tricky to understand where each path is going to lead. To handle that complexity, we can utilize process map abstraction or event log filtering, or we can also combine the both of them. So what is abstraction? Common process mining tools provide abstraction capabilities to simplify process maps. For example, to show only most frequent activities or to show only most frequent arcs. So a process map that you can see on the right here will be turned into a much simpler and a much more understandable process map. Additionally, some tools like Apromore, for example, offer further abstraction capabilities to, for example, show only least frequent activities, least frequent arcs, fastest or slowest activities, or fastest or slowest arcs. And this is usually done via simple sliders that the user can simply modify to set the correct abstraction level as necessary. The second part, or the second approach for handling this complexity, is actually to apply log filters. Log filters allow us to reduce the number of cases or process instances that we are going to look at any single time. It allows us to, for example, set attribute filters, which are going to retain only cases such that at least one event fulfills a condition over one or more attributes. For example, at least one event where activity is close order and resource is ain't allman. We could also do performance filters, for example, to retain only cases that have a duration above or below a given value, more than 3 days, for example. Or path filters, where we can retain traces where there is a pair of events that fulfill a given condition. For example, create invoice is eventually followed by create purchase order. Or we can also do repetition filters, where we get to retain only cases where activity review order is performed 3 times or more. Each of these filter types is very useful to understand and to be aware of, and actually there are many more filter types available, and some of those are going to depend on the tool that we are using. However, now let's take a look at how those filters actually look in Apromore. So this is the BPMN model that we discovered in the previous part of this lecture. Let me first of all go back to the process map view, as it is a bit more compact and easier to understand. Now when I mentioned process map complexity, then this map looks quite simple and easy to understand. But the reason is actually that most process mining tools, including Apromore, when you discover a process model, they are going to apply some abstraction by default. And in this case, we have arcs here set to 10%, meaning that we are going to see roughly 10% of all the arcs actually present in the event log. Let's set it to 100 to get the full process map. Now this looks much more complicated. It is actually the same picture that I showed to you on the slides. But this is quite hard to understand, so let's go down back to, let's say, 25. Now this is a bit tricky, but it's already almost understandable. Let's go to 20. Now this is very easily understandable. And just as a comparison, one thing to note here is that the abstraction can hide important or relevant information. For example, in here, we can see a clear process map. But if we go from 10 back to 20, then we can suddenly see that there is potential reworks in the process, back and forths. There are loops that suddenly occur. So this is something that we have to keep in mind when applying and working with abstraction levels or abstraction settings. The second way of handling process map complexity is by applying filters. Now here it is important to note that filtering is not only for handling process map complexity, but it also allows us to focus in on a specific set of process instances that we are currently interested in analyzing in more detail. But essentially, filtering allows us to remove some process instances from the total set of process instances that we are going to analyze. To begin with filtering, we go here, we open the filter view. Now this view allows us to filter the event log in a variety of ways. One of the ways that we mentioned on the slides is through attribute filtering. So let's say that we want to retain all the cases where the event attribute activity, and by the way, the name of the activity can be seen as a one event attribute. So here we are relying on that intuition. We are using the activity, and we want to focus on, let's say, cases where release type A occurs at least once. Here we can already see that this is going to give us 63.9% of cases. So let's click OK. The filter is here shown, and once we click OK again, then we can see that the process map has now changed. We are now left with only the cases where release A occurs. Since the process map is now simpler, we can of course increase the abstraction level or increase the number of arcs that are going to be shown. When we increase it to 30% or roughly 30%, then we can see that the process map again is slightly perhaps too complicated, but we can see a greater amount of details than before. Let's apply another filter. So let's keep the retain all cases that contain activity release A, and let's add, for example, a performance filter. Let's say that we are only interested in cases that are going to end in less than 2 weeks. Less than or equal to 2 weeks. We are going to, again, click OK, and we get that now we would be left with 51.4% of all cases in the event log. Once we click OK, then both filters are applied. Unfortunately, it doesn't seem that the map became much simpler, so perhaps let's add another one. Let's say that we are interested also in reworks or repetitions. Those we will find here under rework filters. And here we can see all the activities in our event log, and we can see the maximum values that those have. And let's say that we are interested only in cases where admission NC occurs 2 times or more, and we are going to retain those cases. Let's click OK, and now we are left only with 20.5% of all cases. Once we click OK, we can now see that the process map has become also much more simpler again, which is going to allow us to again increase the level of detail that we are going to use to analyze this process map further. While this seems like a bit complicated process map, again, it isn't actually too bad, because we can already see here by the thickness of the lines what are the main pathways, and we can also see what are the less common pathways. In all, I would say that this process map is not too bad. Maybe it is a bit tricky to understand, but it's easily workable. One additional thing to note here is that those filters that I just showed, those can actually also be applied in order to perform some conformance checking tasks. And this leads us nicely to the second technique of process mining, which you might have already guessed is conformance checking. Now in conformance checking, in addition to having an event log, we also need to have some kind of a set of business rules against which we want to check the process executions or it can also be in the form of an actual normative business process model. And as a result, we are going to get information on which process instances comply with the set of business rules that we have, or with the normative model that we have. Now, as we saw in the first lecture, we could obviously do it such a way where we have an actual model of the process created by hand or discovered, and we are going to compare it against the process map that is automatically discovered from the event log. And for example, in here, we can see that there are, in reality, 2 additional activities that are not even modeled in the process itself, but they are performed in reality. Also, we can see that there is a wide variety of different paths, almost none of which are actually present in the model process. Another way to go is, as I mentioned, based on business rules. So oftentimes, we do not have a full process model available, or that full process model is out of date, for example. So in those cases, we have a set of compliance rules. For example, certain tasks must be executed in every case, or certain tasks must be executed at most once. Or when a task A occurs, another task B must also occur within, for example, 2 hours. Or 2 tasks, A and B, cannot be executed by the same person, which would be known as the 4 eyes principle. Now in Apromore and similar tools, we will mostly use log filters in order to set those business rules and use them as filters to figure out which are the cases that do not comply with those rules, and then we are going to look deeper into the process map itself. However, there are some other tools that allow for declarative process rules, for example RUM, and those will be covered in a future lecture. Additionally, in conformance checking, there is also the option of doing trace alignment. That is, automatically detecting differences between a process instance and the given process model. For example, this would allow us to detect skipped or unforeseen activities, or to figure out if there are some control flow differences in a visual manner. And a result of trace alignment might look like something like this, where we can see that register occurred correctly, analyze defect occurred correctly. However, then the process instance deviates, goes to repair simple, inform user, and then the process instance goes back to the way that it is defined in this specific model. And now let's demonstrate how those approaches actually work in Apromore. First of all, let me reset the view that we have right here by removing all the filters that we defined previously. This can be easily done by this button. Here it will ask me to confirm, which I'm going to say yes, and I'm also going to set the abstraction level back to 10. Now if we are going to do conformance checking based on a visual comparison to another process model, then that is quite straightforward. Essentially we would be just following the events, the paths between them, and comparing those to the model that we have at hand. The second part of conformance checking that I mentioned on the slides is through filtering. While it is going to be very similar to what we did, or even exactly the same that we did for process map simplification, let's go through an example just in case. So let's open a filtering view. Let's say, for example, we want to do a path filter. And let's say that in our case, we want ER registration to be eventually followed by ER triage within 2 hours. So this would be quite similar to a business rule where we have defined that ER registration has to be followed by ER triage eventually, and the time distance or the time interval between those 2 activities has to be within 2 hours. So that would be our performance metric in this case. So we have set up the filter. We are going to click OK, and we see that this kind of a performance metric is actually met in 99.4% of cases. But let's say, for example, now, since we have those cases where it's not met, we would like to see them. So we could change the intervals here, or, for example, we could stay with the same interval, but here we could say that instead of retaining the cases that match this criteria, we are going to remove them. So if we do that, then we are left with only 0.6%, or precisely 6 cases. And those would be, for example, the cases that we want to look towards. And given that now we have so few cases, we can also increase the abstraction level quite significantly. And here we can easily see what are those cases, what are the pathways here. And in the next part of this lecture, I'm going to show you even how to see those individual cases. And finally, on the slides, I also showed you an example of trace alignment. So let's take a quick look at how that actually looks like. For this purpose, I'm going to go back to my workspace, and I'm going to actually choose a different model that I already have pre-prepared, which is device repair, and I'm going to hold Ctrl and select also the corresponding event log. And in order to do trace alignment, I'm going to click on Analyze, and here I'm going to click on Check Conformance. This is going to open up a view where I have the model. So this is what my model actually looks like at the moment. And here I have case variants. I'm going to click on, for example, this one, where I can easily see that this case variant follows the process up until analyzing defect, after which it's going to do a simple repair, which is not present in my model. Then that the repair is being tested, which is present in my model. After test, the user is informed, again something that is not in my model, and finally the repair is going to be archived, which again is in my model. So this can be a very useful way of understanding especially difficult process instances. This concludes this part of the lecture. In the next part of the lecture, we are going to look at performance mining and variant analysis.